We kind of alluded to pointers already with the dynamic array concept. We kind of want to make sure that we get this across so that there's no confusion. So, like we said before, pointers are just simply they're pointing at a memory space. So in this example here, we have variable pointer 0 through 3. And you see that pointer 0 is pointing at memory address space 00, which is 64. And 1 and 2 are actually pointing at the same memory space, 10, which is AF, and 3 is pointing at FF. So one important thing to know is when pointer 1 changes the value that is in 10, pointer 2 is affected. And you don't actually have to say, hey, pointer 2, this value's been updated. Pointer 2 is just pointing at that memory space.
So to think of this in physical terms, if you were to go to a library probably in the 80s, I don't know if libraries are still like this, there was the Dewey Decimal System.
You're talking about Dewey Decimal System?
Absolutely.
Oh, yeah.
So you go to the Dewey Decimal System and you pull out the cards, and you go to the card that you want and you pull it out, and that is pointing to a book on a shelf somewhere. So you take that card, and that tells you where to go get the book. You go to get the book, and you take a highlighter, and you highlight some text in there. You put the book back. Mm-hmm. Now, somewhere else in that card catalog, somebody accidentally copied the card that you had and put it somewhere else. Mm-hmm. So you leave and you tear up your card or you take it with you. Somebody else takes that other card and goes to that same location of where the book is. Let's say there was 2 authors, so they put the card in 2 different locations, but they pointed to the same book location. Mm-hmm. Now that other person goes to take that book out, and they'll see the highlighting that you put in that book.
Right.
So that's kind of a easy physical representation. Mm-hmm. Next is the idea of input and output. You will see a lot of references to input and output. Input and output is usually found in a console or a terminal. The way you interact with something, the way files are read, sockets are handled. So, for example, if you write text to a screen, you're outputting that text to the screen. When you type on a keyboard, you're inputting your keyboard input into the computer. When you request a web page, you're uploading the request to the web server, so you're inputting your request into the web server, and then that web server will output the result back to your browser.
Yeah, that's why we mentioned sockets fit in both in this case. Yeah,
yeah, and you can reverse. So input and output, although is subjective to the eye of the beholder, it's still generally universal to the idea that the human inputs to the computer outputs to the human, in a general sense.
Or a program outputs to something and then it gets it back.
Correct.
Right. if it's automated. Dependencies in libraries are important to understand because some of you guys that start running on this will go download a piece of Visual Basic or C# source code and compile it, and it's going to say, "Oh, you don't have this library. Sorry." Well, it's because you don't have the necessary dependency in order to have the ability to run that program or compile that program. So generically speaking, it's any piece of code, any either compiled or uncompiled library or framework or executable that is required for a program to either execute or to compile. And a very basic example of this is those of us that are fortunate enough to be able to walk, you had to learn how to stand in order to walk. So the program in your brain that says, I'm going to get up and walk over there, has to import all of the knowledge that you learned as a baby standing in order to do the walking, because you can't walk without knowing how to stand. Mm-hmm. So that is in this example, that is your dependency. And to kind of move this into the programming aspect, so how does this relate to programming? Well, let's say in C++, if you want to write something out to the screen, like we were just talking about output a second ago, that can't possibly happen unless you import the input-output stream dependency or library so that the C++ program knows how to communicate that information to the screen.
Another core concept is the concept of a function or a method. So a function call will be something like, what is the length of a string? What is the power of these 2 values? So a function is a chunk of computer code that executes and returns a value within a larger program. And it's usually for a particular reason. Sometimes these are called procedures, sometimes these are called subroutines, procs or subs. And a function performs the same action is accessible throughout a program. A method is basically a function, but a function that's contained within an object. Mm-hmm. So methods are found in object-oriented programming. So if we haven't really got too much into object-oriented programming, but an object can contain a variable and a function and other things. And the function that's contained within that particular object is referred to as a method.
one thing to note about functions that's important is not a lot of times, functions are part of the modularity concept in software development, which is extremely important to know because that's how software is written. You would never, I don't want to say never because I've read some terrible code. If there's a situation where your computer program has to do something multiple times, why would you copy and paste that code and rewrite it over and over again when you could have a 200-line piece of code and you can make it 5 or 10 lines if you just subroutine out the processes?
So let's say you implement your function and you write it 100 times over throughout your program.
Mm-hmm.
You start testing your program and you realize it doesn't work in all conditions. So now you need to update that type of action. Now I have to update it 100 times and hope that you're consistent.
Yep.
But if you have it in a function, you just update it once in that function.
Mm-hmm.
And the next time that you go to write a program, if it's a common enough action, you can just use the functions you've written before.
Oh, yeah.
And just call them.
If you're smart, you'll write it in some sort of a class structure that you can reuse over and over and over again.
Yeah, a series of commonly used functions can be packaged up into a library that can be used later.
Yep.
For convenience.